Hello friends, our topic for today is matrices. We are going to study about what a matrix is, about elements of a matrix, about order of a matrix. We are going to study about the rows and columns of a matrix, the different kinds of matrices, whether two matrices are equal or not, and we are also going to study about addition and subtraction of matrices. Now, what is a matrix? A matrix is a rectangular arrangement of numbers in rows and columns. Where have you come across it? All of you have been to a cinema hall? In a cinema hall, you see the seats numbered as A1, A2, A3. Now, what do these A1, A2, A3 indicate? These are indicating the row number as well as the column number of the seats. All of you who have computers have done computer programming where you do data sorting. You use arrays. So this matrices is a concept which is used in arrays, and that is why we are able to sort data. Okay, now if A is a matrix, with elements as 1, 2, 3, 4, 5 and 6, you need to separate the elements by spaces, and you can write the matrix A in big bracket or in small bracket. For naming a matrix, we use one capital alphabet, and for writing the elements of a matrix, the matrix itself, we use big bracket or we use small bracket. Now, in this example, there are two horizontal lines of data. Each horizontal line is a row of the matrix. This is the first horizontal line, first row. This is the second horizontal line, the second row. And there are 1, 2, 3. 3 vertical lines, 3 columns in the matrix. Now, since there are 3 rows and 2 are there 3 rows? No. There are 2 rows. Since there are 2 rows and 3 columns in the matrix, we say that the order of the matrix is 2 by 3. The first number over here stands for how many rows are there, and second number over here stands for how many columns are there in the matrix. In a matrix, we may have only one row and one column. Example like this. In a matrix, we may have 2 rows, 3 columns, 3 rows, 2 columns, depending on our need. Now, let's study about the different kinds of matrices. Now the matrix A has only one horizontal line in it. It has only one row. A matrix in which there is only one row, there may be any number of columns. Here there are 3 columns, there may be 4 columns, there may be 1 column. A matrix in which there is only one row of data is called a row matrix. Now in this matrix B, there is only one column of data. So such a matrix is called a column matrix. What about matrix C? The number of rows and the number of columns is same. There are 2 rows and there are 2 columns. So such a matrix in which number of rows equal to number of columns. There may be 1 row and 1 column only. There may be 2 rows and 2 columns, or 3 rows and 3 columns, and so on. Such a matrix is called a square matrix. In a square matrix, number of rows equal to number of columns. Okay, now what is so special about this? In this matrix, each and every element is 0. So this kind of matrix is called a zero or null matrix, and we denote it with a capital O. You have studied about zero, the simple number zero in mathematics. Now, if you have to add a number, say 5 by 0, what do you get? You get the number 5 itself. So 0 is the identity element for addition when we take natural numbers, whole numbers, integers. Same way, over here also, 0 matrix is the identity element for addition of matrices. It is the additive identity. So we have studied about a row matrix, a column matrix, square matrix, zero matrix. And what is this? This is very special and very important. This is the matrix which we name with I for identity matrix. So if you have 1, 0, 0, 1, all the elements over here are 1, and this is called the principal or the leading or the main diagonal. This is the principal or the leading or the main diagonal. There are two diagonals over here. One diagonal is like this, one diagonal is like this. You will take this diagonal. So these are the elements on the principal or leading or main diagonal of the matrix, and all of them are 1. Elements on the main diagonal, principal diagonal are 1, and the others are 0. Let's discuss in detail about identity matrix. Identity matrix is also called unit matrix because if you multiply any matrix A into I is equal to I into A is equal to A itself. So I is the identity element for multiplication of matrices. You'll get a matrix back if you multiply it with I. I is identity matrix or unit matrix. I1, if we write, it means that this square matrix, this identity matrix, which will always be a square matrix, will have row 1 and row 1 and column 1. If I give you I2, it will mean that the identity matrix will have 2 rows and 2 columns. If I write I3, it means the identity matrix will have 3 rows and 3 columns. Now, what is I1? Remember, the elements on the principal diagonal or leading diagonal or main diagonal have to be 1. So, I1 equal to 1. Elements on principal diagonal have to be 1, rest 0. So, 1, 0, 0, 1. Please learn it up very nicely. You will need it a lot. Again, if you have I3, elements on the principal diagonal will be 1 and the other elements will be 0. So, we have discussed about row matrix with only 1 row, column matrix with only 1 column, square matrix in which number of rows equal to number of columns, null matrix in which each and every element is 0, and we have discussed about identity matrix in which elements on the principal diagonal are 1 and the rest are 0. Now let's do some sums about what we have learned. One more thing I would like to discuss is, when are two matrices said to be equal? Two matrices are said to be equal if the very first thing is their order should be same. This is a 2 by 2 matrix. This is also a 2 by 2 matrix. Two matrices are equal only if their order is same and elements in corresponding positions are same. So, first row, first column, we have A. First row, first column, we have 1. So, if A is equal to B, matrix A equal to matrix B, then A will be equal to 1, B will be equal to 2, C will be equal to 3, and D will be equal to 4 because these are the elements in the corresponding positions. If it is given that a matrix has elements Aij, okay, now what is the meaning of Aij? Aij refers to each and every element in the ith row and jth column of the matrix. So, if I give you that a matrix has order 2 by 2 and you are supposed to form the matrix under the condition that Aij equal to I into j. How will you do it? I refers to the row number, j refers to the column number. So if there is a 2 by 2 matrix, there will be a total of 2 rows and 2 columns. So the elements which we'll have will be element in first row, first column, element in first row, second column, element in second row, first column, element in second row, second column. So I1, J1. If you put I1 and J1, 1 into 1 gives 1. If you put I1, J2, 1 into 2 gives 2. If you put I2, J1, you get 2 into 1 which is 2. I2, J2. 2 into 2, 4. So if capital A is the required matrix, the element in the first row, first column is 1, 2, 2 and 4. I'll briefly recap what we have done. Each element of a matrix, see, capital A is reserved for the name of the matrix and small a refers to each and every element in the ith position, ith row and jth column. So if it is given that the formula for finding each element is Aij equal to I into j and it's a 2 by 2 matrix, then there can be a total of 2 rows, meaning you can have row number 1 and row number 2. 2 columns, meaning you can have column number 1 and column number 2. So A11 we'll get by putting I as 1 and j as 1. 1 into 1, 1. A12 we will get by putting I is equal to 1 and j is equal to 2. So 1 into 2 gives us 2 and so on. I suggest you write the elements separately, row wise, the way I have written. It will be easier for you to write the answer matrix. If you have been given that the two matrices A and B are equal, okay, you have A in 2 places, you have B in 2 places. For equality of matrices, we need to first check whether the order is same. Order is same, okay. Now we need to check whether, now we need to say that the elements in the corresponding positions will have the same value. This is simpler than A plus 3. Again, B and B plus 1. B is simpler than B plus 1. Though we can use the corresponding positions for any of the 4 elements. If your work can be made simpler, it's better. So what should be the value of A? A should be equal to 1. First row, first column of A, first row, first column of B. And what will be the value of B? The value of B will be 5. You need not do further calculations, but just to cross check what we are doing is right, let's check once. If you have A plus 3 and A is 1, 1 plus 3 is 4, so the same 4 we are getting and this will always happen. Now B is 5 and B plus 1 will become 6, so we have verified that whatever we have done is correct. Now let's talk about addition and subtraction of matrices. Two matrices are said to be conformable or compatible for addition subtraction if and only if their order is same. Remember, in algebra, if you didn't have like terms, you couldn't add them. Only like terms could be added. Similarly, over here, you can add matrices only if their order is same. A matrix like this cannot be added with a matrix like this. Why? Because the order over here is 2 by 1 and the order over here is 1 by 2. Until and unless the order is same, we cannot add. If we have a matrix A equal to 1, 2, 3, 4 and it's given A plus X is equal to 3, 5, 7 and 8, and you need to calculate the elements of the matrix X. How will you do it? The way we do in simple equation, same way you can transpose elements over here, transpose a matrix over here. So this will imply X is equal to 3, 5, 7, 8 minus A. If you substitute the value of A, you will get 3 minus 1, 2, 7 minus 3, 4, 5 minus 2, 3, 8 minus 4, 4. So children, I hope you have understood how to add or subtract matrices. If you have something like this, you want to calculate the value of X. So you take this side plus A. When it shifts to after equal to sign, it will become minus A. We substitute the value of matrix A over here. 3 minus 1, 2, 5 minus 2, 3, 7 minus 3, 4 and 8 minus 4, 4. This is how we add or subtract matrices. Let's take another example. Instead of writing like this, I could have also written capital O, which stands for null matrix. Okay, now if you have to find the value of X over here, again what you should do is first transpose, it's easier. A goes that side, becomes minus A. Minus B goes that side, it becomes plus B. So minus B, when it is coming after the equal to sign, it is becoming plus B. Children, I want to emphasize one thing. Don't try to do the entire calculation together. Go a little slow. So first subtract and you will get minus 1, minus 3, minus 2, minus 4. Now take the third matrix. So first I added the first two matrices. First I subtracted the second matrix from the first. After doing this, I am adding the result with the last matrix. Now if I add minus 1 and minus 1, when added give minus 2. Minus 2 and minus 2 on addition give minus 4. Minus 3 and 3 when we add we get 0. Minus 4 and 4 when we add we get 0. Any problem? Okay. Now suppose I give you two matrices which add to this, and when we subtract we get this. Any idea how to do such a calculation? Where have you seen such equations? There are two missing matrices over here. When we had two missing variables and equations, when we had two linear simultaneous equations, how did we solve them? Let's apply the same concept over here. If we add the two matrices, if we add the two equations, plus y and minus y get cancelled, x plus x gives 2x. And if you add these two, 5 plus 1 gives 6, 6 plus 2 gives 8, 7 plus 3 gives 10, 8 plus 4 gives 12. One thing I want to explain, please understand what is the meaning of 2x. 2 is a scalar. It is a number, it's a constant, it's a scalar. If a matrix is multiplied with a scalar, the matrix X is multiplied with the scalar 2. So if you have anything like this, A is equal to 3 and 4, then what will be 2A? I am multiplying the matrix A with the scalar 2, so each and every element will be multiplied by 2. 2 into 3, 6, 2 into 4, 8. Please understand, if you have scalar matrix, if you have the multiplication of a matrix with a scalar, each and every element of the matrix is multiplied by the scalar quantity. So over here we have 2x equal to this much, but we want the value of x, so we need to remove the 2. By cross multiplication, the 2 will come down here and we'll get 6, 8, 10, 12. And what is this? This is the scalar half, and every element of this matrix has to be multiplied by the scalar half, or you can say every element of this matrix has to be divided by 2. And what do we get? We get 3, 4, 5 and 6. Children, I hope you have understood this. If you have any doubts, do get back to me. So that's all for today. Thank you so much.